In this video we are going to discuss about third step of simulation, and it is load and boundary condition, that how we can apply load and constraint that are associated with CAD geometry. Fundamentally, constraint is all about blocking the movement of structure in specific direction. Basically, we have a translation constraint and rotational constraint. We also call it as a degree of freedom. To define the joint and connection available in structure or assembly, we have to define different type of constraint, and there is a multiple way to define constraint. We will see into the next slide. The important thing is, in the Simcenter, the constraints are defined on CAD geometry, and they are independently of specific mesh distribution. So if there is some change later on into the geometry, the constraint will automatically update. So in demonstration 3, we will see that how we can define translation constraint. So we know that this cover is going to screw with other body or other component, so I do not have geometry or representation of other geometry. So how we can define that this cover is not going to move in any three direction? So we have to block three translation degree of freedom, and for that we need to apply a fixed constraint or fixed translation constraint to the support face of this cover, and it is good to idealize and simplification with respect to the reality. The another way to define a translation constraint is that we can use the 1D type of element. That I know that in this circular hole there is a bearing, and we know the bearing has a stiffer material than aluminium. So this circular geometry remains circular during the operating condition, and I want to represent that. So using a 1D type of rigid element, we can represent that this circular geometry remains circular. So there is a multiple way to define a constraint, and in this case we will use a 1D type of element to represent the effect of other geometries. So we know that most of the system and structure has some type of load, and in simulation model, loads are applied to represent the force and moment acting on the structure. So we have different type of load, such as point force and momentum. We also have a pressure load, so we can use a distributed force to represent pressure loads. In some assembly or mechanism, there is a part and they are rotating, so it will create a centrifugal force. So to represent that, we can use or represent the inertia force. And the important thing is that in the Simcenter, that the load are defined on the CAD geometry, and they are independently of specific mesh. So if there is some change later on into the geometry, it will automatically update. Let's move toward demonstration 3, that how we can define load and boundary condition in Simcenter. Here you can see that right now we are in FEM modeling environment. So let's switch to simulation environment. Here in simulation environment, we have a different type of tool that can help us to define load and boundary condition as per real world operating condition. So Simcenter offers us wide range of constraint, such as we can define a user defined constraint that we can play with 6 degree of freedom as per our requirement. We can also constrain all degree of freedom by applying fixed constraint. We can also define, or we can use a fixed translation and fixed rotation type of constraint. Simcenter also offers a special type of constraints such as slider, pin, and cylindrical type of constraint, so we can use it as per our requirement. In our case, this aluminum cover is going to screw on other body, so this support face will not move anywhere in three direction, x, y, and z. So we can define this situation by applying a fixed translation type of constraint. So let's create a fixed translation type of constraint for this support face. The important thing is that what we will define is directly associated with our polygon geometry, and if there is some change later on, the defined boundary condition or constraint will automatically update. Here selection filter offer us whatever we want, we can select as per our requirement, and in our case it is polygon face. So let's select it and create a fixed translation type of constraint for our cover. So it's look bit messy, so for better visualization I will change the presentation of constraint, and this look good for me, so let's move forward. I know that there is a shaft passes through this circular hole, and power transmission shaft will mount on some type of bearing, so we know that bearing has a stiffer material than aluminium. So I want this circular geometry remains circular, because during the loading condition this circular geometry remains circular. So I can define this type of situation by defining cylindrical constraint, but in our case we are going to use special type of 1D connection. So let's switch back to the FEM modeling environment. Here we can use 1D type of connection to represent that the circular geometry remains circular. So we will connect all edge element to the center node using a 1D type of rigid element. So let's create a node at the center, and let's select our target edge, and we are going to use RBE2 type of 1D element. It is a rigid type of 1D element, so it's look good for me. We can also visualize what we will get. So it's connect all the element on circular edge to the center, so it's look good for me. So let's move forward. So for better visualization I will change the color of this 1D type of element. So let's go ahead and apply this color, so it's look good for me. I also want to create a 1D type of spider element to the upper edge of this circular geometry. So let's create a center node and select the target edge, and it's look good for me, and I'm going to put this into the same type of collector, so it is look good for me. Let's create a 1D type of connection for upper edge. So what I have created, it's good as per my real world operating condition. So by defining 1D type of element, I represent that the circular geometry remains circular during the operating condition or loading condition. So let's switch back to the simulation environment that I have and I have data that this cover as a pressure, that 3 atmospheric pressure is applied on this upper face of cover. So Simcenter offers us a wide range of load that we can define as per our requirement. We can define acceleration, we can define force, we can define bearing type of load. If there is some twisting moment, then we can define a torque. In our case it is a pressure, so let's create a pressure. The important thing is that we can define a magnitude of load as per our unit system, and software will automatically convert into the default unit system. So in our case it is atmospheric, so we are applying 3 atmospheric pressure at the upper face of this cover. So let's go ahead and create a load. So the created load is associated with the CAD geometry. So this way we can easily and rapidly define load and boundary condition in Simcenter, and what we are defining is directly associated with CAD geometry. So if there is some change later on into the geometry, the defined load and boundary condition will automatically update. In following video we will discuss about last step of simulation, and it is solving and post-processing, that how we can set up simulation and solve it, and how we can interpret our result using post-processing tool available in Simcenter.